Okay, let's talk about other types of things that we can do with our SOQL queries. A very important keyword that we can use is the in clause. And what we can do is we can apply this to something like our where clause and do a bulk query. So one of if we think about when we're working, we're going to talk about triggers in a second. We're working with large amount of records. What we do not want to do is we do not want to go out to the database in multiple trips. Instead, we want to do something like collect a list of IDs of records or a set of IDs of records or some sort of criteria, like let's say we're searching for a number of colors, but to collect all the criteria that we're looking for, do a single query where we're using in to go out and fetch all the results with one query. Like can be used for a fuzzy text search. So for instance here we're looking for positions that begin with senior. And or. And is for creating compound, obviously multiple conditions, same with or. Not negative conditions. We can sort the results that we get back from the database using the order by. There's an ascending and a descending for the order that we want to return based on that field. The syntax would be order by last name, and then you do ascending or descending, with ascending being the default. There's also the group by. So we can utilize the group by to do things like a subtotal. We can calculate averages for those subgroups. But what we do is we indicate the field that we would like to subtotal. So for instance, in this case, here we have candidates in which we're grouping by zip code. And in this case, we're also counting the unique instances of those candidates based on the non-null name field. Now, a very important point to point out here is that notice that we have this aggregate result. And we've never talked about aggregate result before. There is the SObject base class, and then all our standard and custom objects are children of SObject. But there is a special exception to that, which is the aggregate result. An aggregate result is the one type of SObject which is not a concrete, custom object or standard object that exists within your database. Its purpose is to be this sort of, how shall I put it, this flexible result type where when we do something like we calculate a subtotal like we're doing here, we need to be able to have a result that is not bound to a standard or custom object, and we need to be flexible enough to be able to access that subtotal. So what we would do in the aggregate result is, in this case, by calculating that subtotal, a default field is going to be on the aggregate result called EXPR0. And depending upon the number of calculations that you have, what it does, the order in which they appear, we have EXPR0, EXPR1, so on and so forth. On this aggregate result, using the SObject methods that we talked about previously, get and put, if I want to access the subtotal that was calculated, I would do, in this case, let's say each of my aggregate results, I called them an AR. I would do AR.get and then access the string EXPR0 and then cast that into whatever data type, in this case an integer, that was being calculated. Okay? Same thing goes for the, in this case, if I'm selecting the zip postal code, I'm also going to need to use the .get because the aggregate result doesn't know of a field called zip postal code. So I can't use dot notation in that case. I can't treat it as a concrete type. Okay? Another thing that you can do is you can also use aliases. So here, I might also, right after the parentheses, create an alias called subtotal. In this case, what I'd do is instead of accessing a field called expr0, I'd be accessing a field called subtotal, whatever I called it. So a lot more readable code if you use those aliases. Okay? All right, limits. Limiting of the results comes into play when we think about what we might do within our governors. One of the things that you might do is to prevent yourself from exceeding a governor limit, you might use the limit and then use your limits classes to make sure that you don't exceed the total number of rows that you get back. So if you think about when you're performing the query, you have a limitation in the governors for each synchronous transaction of 50,000 records. So let's say that I'm doing something where I'm creating maybe a Visualforce application, and conceivably one of the users of this application, they might configure it to go out and do a search for every contact in the United States. And so now they're going to get back, let's say, 500,000 contacts. In this case, we have a situation where we're going to conceivably exceed that governor limit. What we can do is we can write our code to prevent that from happening using those limits classes by using the limit and then saying, all right, let's take our ceiling number and then let's subtract the number of rows that have currently been fetched. That is our limit at this point in time. Let's only request that many rows from the database. Then what we can do is we could then display an error message or a warning message to the end user. You need to refine your criteria because there are more records out there that I could have fetched, but I had to limit them based on the fact that we're returning too many. Okay. When you use the order by with the limit, it acts as a top. So the first thing that it does is it sorts the list, and then the second thing it does is it applies the limit. So in this case here, this order by years of experience descending, limit 25, what this is going to do is this is going to return the top candidates based on their years of experience, the most years of experience. For update is going to lock the rows that you've selected. So the idea behind this is that if you are selecting some rows, you don't want another transaction going through the system to update the same records and then you overwrite the changes that were just made because your transaction happened to be taking a longer period of time. So what we can do is we can do the for update, which will establish a lock on all the records, on all the rows that you've selected from the database. Now the way that this works is that it is optimistic for a certain amount of time, which is to say if another thread is going to access those rows, it's going to simply wait. But there's a timeout on the amount of time that it's going to wait. And after that period of the timeout is expired, it's then going to return an error, or the other thread will receive an error basically saying that the rows are not available. When the transaction is ended, the lock is given up. And the timeout, I don't have an exact number on the timeout. I've seen 5 seconds and I've seen 10 seconds. So I'm not sure about the actual time that the other thread will wait in order to access those rows. All rows. All right, so what all rows does is, first of all, let me explain something about deleting records within Salesforce. When we delete a record in Salesforce, we don't actually hard delete it. What we do is we move it to the recycle bin. Now there are two important things that occur there. One is that there is a field, which is, you'll never see it within the tool per se, but there is a field called is deleted. So is deleted is going to be set to true, and on top of that, from a sort of a system standpoint, the record has been moved to the recycle bin. So when we're performing a query, there are both of these things that come into play. So first of all rows will say, go out and do the query not only across my active records, but also records that are in the recycle bin. If you only want records that are in the recycle bin, then what you're going to do is you're going to check to see, does isDeleted equal true? Okay. So if you're searching just for records that are in the recycle bin, both of those need to be performed. Now there's another option or another DML operation which we have not talked about yet called undelete. And what undelete does is undelete will exhume a record from the recycle bin and then reactivate it, make it an active record again. And so we'll talk about this when we get to our DML section. But undelete would be used specifically in this type of situation where we've created a query like this and we're going out and fetching records which are only in the recycle bin. So let's talk about some of the things that we talked about relationships, the double underscore R, the double underscore C. And let's talk about how we can do join-like queries within SOQL where we want to fetch records and then associated parent data, or fetch parents and associated child data. So I'm going to walk you through 6 examples of different types of queries which combine data from related tables. So here we have, let's first take a look at our sample data that's up here. We have the job application and we have the position. And the job application is the child in this case. It has a lookup relationship to the position. In fact, something about the job application table indicates that this is a lookup relationship and not a master detail relationship. So if you take a look at app 70, notice it has a null value. This is a lookup relationship. So having a null value, having a child without a parent is perfectly okay, which is not okay with a master detail. Notice the colorization that we've done. The programmer ID is highlighted in blue, and then our account executive is highlighted in green. And we can see those related, or the job applications that are associated with those positions based on that color coordination. Okay? All right, so in our first example, we're going to do a right outer join. Okay? So if we were to do some pseudo type of language for what we're looking for, we want to get job applications and the associated position data. Okay? So in this case, what we would do is we'd be selecting from the job application object. But notice how we're going to use the double underscore R syntax. So we're going to use the position field, and what we're going to do is we're going to use position double underscore R to traverse up to that position table, and then do dot name to access a field on that table. Okay? What this is going to do is this is going to return a list of job applications. So important point to make right here is that notice that my return type is still strongly typed based on where I'm selecting from. Okay? I get back a list of job applications, and where there is a value for the department, we return it. Otherwise, if we attempt to read it, it's just going to be null. Okay? But it's a single result. All right, let's do a left outer join. So what we're going to do is from our position table, we're going to be selecting positions and the related job applications. Okay? So what we're going to do in this case is we're going to do this sort of subquery. So first of all, let me point out that we're selecting from the position table. So in this case, we're selecting a field from the position table from the left side, and we're selecting the value of the name field. And then what we're doing is we have that subquery, and it says go out and select name from job applications double underscore R. So in other words, from the perspective of the position, go out and select the related job applications. In this case, what it does, what would be my return type? List of positions, exactly. So in this case, what we get back is we get back a list of positions. For the job applications double underscore R, this is going to contain a reference to a list of positions. So in the first one, where I'm selecting my programmer, what we get back is a list of job applications when we access this field. And then here's the value of the name field, and then same thing for the account executive. So what would happen in this case is if you don't find the records, you're just going to get back an empty list of the job applications. In order to access all of the data that you fetched here, you'd need to create an outer loop for all of your positions and then an inner loop for all of your job applications. Okay? A semi-join, which is, you can also think of as a left inner join. And so what we're going to do is we're going to do an intersection between our positions and our job application table. So only get positions that have related job applications. So what we're going to do is we're going to select from position, and then we're going to do our where clause, where the ID of the position is in the result list that we get back by doing this query. So this is going to select the position ID from the job application table, return a list, and we're going to use that list to filter out our positions. So in this case here, we're going to get back our blue and our green IDs from the job application table. Because we're selecting from position, we're going to get back our programmer and account executive, our list of positions. Okay? Now, if we do this from the right side, what we're going to do is we're going to select from the job application table, and then here we're doing where position is not null. Pretty straightforward. So anywhere we have a non-null value in that position field, we know that we have an associated parent. In this case here, we get back a list of the job applications that have positions. Now if we do this with the anti-join, so we only want to get job applications that don't have related positions. Once again, this one's pretty straightforward. We're just going to select from the job application where the position field is null. So in this case, we get back a list of job applications and only app 70. And then we want to do a left anti-join, parents without children. So in this case, we're going to select from position where the ID is not in our list of positions that we just selected from the job application table. So in this case, what we get back is we get back our billing assistant and our product manager records. All right? All right. You can do this up multiple levels. So what you can do is everything I've been talking about with respect to going up levels. So you don't have to limit yourself to parents. You can do queries on grandparents and great-grandparents. You can also, from a parent, select children. You cannot do a subquery inside of a subquery, though. So if you want to go out and fetch grandchildren, you need to fetch the children and then do a separate query using the IDs of the children to fetch the grandchildren. Okay? So going down, you're limited to one level per query as opposed to going up. You can do up to 5 child-to-parent relationships. All right, so the Salesforce Object Search Language. So Saucel is our version of a free text search. So when you go to Yahoo or Google and you do a search for some terms, neither of those systems are backed up by a relational database. They're backed up by search engines. And so the search engines create an index of all the keywords, and you do a search across that index, and it returns the, what are ultimately, it's a, a link to all the documents associated with those. Roughly the same thing going on with Saucel. Allows us to do searches as opposed to structured queries. Okay? So the key advantage, why do this? Well, the key advantage of Saucel is giving your end users the capability to do a search, a single search across many S objects and also many fields on those S objects. So if you think about building up a structured query, you'd have to do, if you're searching across 20 objects, let's say, you'd have to do 20 separate queries, or you'd have to do each of the individual fields that you'd like to be searching in. The search is highly advantageous for searching for that free text search. Because we're searching across multiple S objects when we're doing a SOSL search, the return type is a list of lists of S objects. So our outer list of S objects, or our outer list, is going to contain these lists of S objects. And then here, if we happen to find accounts and opportunities, we can now iterate over each of those types. Okay. The syntax, so the easiest way to tell a SOSL search apart from a SOCL search is all SOSL searches start with the find keyword. And so the idea is we do find, and then we're going to enter in our search criteria. By default, your SOSL searches, they're going to search across the S objects that you specify. It's going to search across all searchable fields. And what we do, these are basically text fields. So we exclude things like dates and IDs and numbers from the generated index. Also by default, it returns only IDs. So you'll only get back the IDs of the records, but we can select field values if we want to. So let's take a look at a very basic SOSL search. So first of all, taking a look at our return type, we get back a list of lists of S objects. And here what we're going to do is we're going to find the keyword Acme, or at least words that start with Acme, out there in our records. It supports the asterisk for one or many characters, or the question mark just for a single character. The in clause can be added to your search, and what this does is it restricts the searching to certain types of fields. Now by default, you're going to be searching across all of those text-oriented fields. But you can limit it just to the name fields, email fields, or phone fields if those are the things you happen to be searching for. Now, let's take a look at the returning clause. The returning clause is going to define where you're looking. And so taking a look here, we have find Acme in the name fields, and we're returning on line 1A, returning accounts and contacts. Now, the way that this works is that the order that you list the S objects that you're searching across, those are the order that you're going to find them in the list of lists of S objects. So because we listed account first, that is our 0th element within the outer list of lists of S objects. So here we can get our list of accounts, and then our second item would be our list of contacts. Now, by default, these only return IDs. Now, if we want to return field values, we'd use this syntax, where we have returning account, and then we have the name and the billing country. So when we fetch those accounts, let's not only grab the IDs, let's also grab the values for the name and the billing city. And then same thing on each object by object basis. An important thing about SOSL searches is that SOSL searches are intended to be done by end users. And by default, or I should say not by default, but always, a SOSL search will return a maximum of 200 results. So the idea is that a SOSL search should be performed by an end user. In fact, you can't execute them from triggers for that reason. The assumption is that you have a custom web service, or you have a visual force controller, something along those lines that the user is interacting with explicitly in order to perform this search. So there's a maximum of 200 results that you'll get back from the SOSL search. There are other, there's a where clause where you can do things like filter out results based on things like here we have created date equals this fiscal quarter, or some other type of filter. So comparing SOCL and SOSL, the key advantage of SOCL is things like, or I wouldn't say an advantage, but when you know the object that you're looking across, then we're going to be using SOQL. When we need to join data from multiple objects, we can do those join-like queries in SOQL. If you want to query beyond text, email, or phone fields. The other thing about SOQL is that SOQL allows us to set, like I was explaining about triggers, SOQL allows us to select data from the context of a trigger. SOSL cannot be used within that context. The primary advantage of SOSL, you're searching across multiple S objects, and you're also on those S objects searching across, at least by default, all of the text fields. So you're searching across many fields for the existence of those keywords.